What is different between clutch and torque converter? If you work with heavy equipment in the industrial setting, two phrases you're likely to have come across are clutch and torque converter. In this video, I will share you their differences. Clutch and torque converter are both components used in vehicles to transmit power from the engine to the transmission, but they operate differently and serve different purposes. Clutch. While there are many related parts, I will show you the only major players in a clutch system on a manual transmission. Flywheel. The flywheel is bolted securely to a flange at the rear of the engine's crankshaft. The clutch disc. A large round disc, typically more than 30 centimeters in diameter, it slides onto the transmission's input shaft. On both flat surfaces is bonded friction material that's commonly semi-metallic like brake pads. The pressure plate is on the opposite side of the clutch disc from the engine. The clutch housing, also known as the bell housing, function is to support, protect, and align the clutch assembly within the drivetrain system of manual transmission vehicles. Pivot as foothold. The function is providing a stable and reliable pivot point for the clutch pedal's movement. Its smooth operation, durability, and adjustability contribute to the overall performance and feel of the clutch pedal in manual transmission vehicles. Clutch lever and cable. They work together to actuate the clutch mechanism, allowing the driver to engage and disengage the clutch as needed depending on pedal movement, whether the pedal is pressed or depressed. A rough layer. This feature can contribute to improved performance, durability, and heat dissipation in clutch disc of the vehicle's clutch system. The retractor clip. It is maintaining tension on the release fork or bearing, preventing rattling, and ensuring smooth and reliable operation of the clutch mechanism in a manual transmission vehicle. Diaphragm spring. Is providing the clamping force necessary for engaging and disengaging the clutch. Its design allows for consistent and reliable operation, contributing to smooth and efficient vehicle performance in manual transmission vehicles. The manual clutch system in a vehicle allows for the engagement and disengagement of the engine from the transmission, enabling smooth shifting between gears. Here's a step-by-step explanation of its working principle. The driver depresses the clutch pedal with their foot, which is typically located to the left of the brake pedal in vehicles with manual transmissions. Depressing the clutch pedal initiates the clutch disengagement process. When the clutch pedal is depressed, it pulls on a cable or hydraulic system connected to the clutch release mechanism. This action moves the release lever or fork, which in turn disengages the clutch by releasing pressure on the clutch disc. With the clutch disengaged, the clutch disc separates from the flywheel. This interrupts the flow of power from the engine to the transmission, allowing the engine to spin independently of the transmission input shaft. While the clutch is disengaged, the driver can shift gears using the gear selector lever or stick. This allows the driver to select the desired gear ratio based on speed, load, and driving conditions. After shifting gears, the driver gradually releases the clutch pedal. As the clutch pedal is released, the clutch release mechanism re-engages the clutch by applying pressure to the clutch disc. This allows the engine's power to be transmitted to the transmission input shaft, enabling the vehicle to accelerate. Proper coordination of clutch pedal operation is crucial for smooth engagement and disengagement of the clutch. The driver must release the clutch pedal gradually and smoothly to prevent abrupt jerking or stalling of the vehicle. The process of engaging and disengaging the clutch is repeated each time the driver shifts gears or comes to a stop. The torque converter is a key component in automatic transmission vehicles, responsible for transferring power from the engine to the transmission while allowing for smooth and variable torque multiplication. Here's how the torque converter works. The torque converter consists of an impeller, a turbine, and a stator, all housed within a sealed chamber filled with transmission fluid. The impeller is connected to the engine's crankshaft, while the turbine is connected to the transmission input shaft. As the engine rotates, the impeller spins, creating a flow of transmission fluid within the torque converter. This fluid flow imparts rotational motion to the turbine, which drives the transmission input shaft, ultimately propelling the vehicle forward. One of the unique features of the torque converter is its ability to multiply torque during initial acceleration. As the impeller spins, it creates a fluid vortex that exerts force on the turbine. The design of the torque converter allows for variable torque multiplication, meaning that the torque output at the turbine can be higher or lower than the torque input at the impeller, depending on driving conditions. At low speeds or when the vehicle is stationary, the turbine may not spin fast enough to match the speed of the impeller, resulting in a condition known as stall. During stall, the torque converter acts as a fluid coupling, allowing the engine to run without stalling while the vehicle remains stationary. As the engine rotates, the impeller spins, creating a flow of transmission fluid within the torque converter. This fluid flow imparts rotational motion to the turbine, which drives the transmission input shaft, ultimately propelling the vehicle forward. At low speeds or when the vehicle is stationary, the turbine may not spin fast enough to match the speed of the impeller, resulting in a condition known as stall. During stall, the torque converter acts as a fluid coupling, allowing the engine to run without stalling while the vehicle remains stationary. To improve fuel efficiency and reduce heat generation, many modern torque converters are equipped with a lockup clutch. The lockup clutch mechanically connects the impeller and turbine once the vehicle reaches a certain speed, bypassing the fluid coupling effect and reducing slippage. This creates a direct mechanical connection between the engine and transmission, improving efficiency during cruising conditions. The stator is a stationary component located between the impeller and turbine. Its purpose is to redirect the fluid flow exiting the turbine back to the impeller, improving efficiency and increasing torque multiplication during acceleration. Likewise, torque converter for heavy equipment. The working principle is exactly the same. One of the key advantages of a torque converter is its ability to provide torque multiplication, which helps vehicles or equipment accelerate from a standstill more effectively. Additionally, it allows the engine to continue running when the vehicle is stationary, such as at traffic lights, without stalling. In summary, the clutch system and torque converter system serves as the connection between the engine and the transmission, but they operate differently depending on whether the vehicle has a manual or automatic transmission. The clutch is manually operated by the driver to engage and disengage the engine from the transmission in manual transmission vehicles, while the torque converter provides automatic and continuously variable power transfer in automatic transmission vehicles. Like, share, and subscribe to our channel for more exciting content about the world of heavy equipment. Thank you for watching and your support.